functions that act as methods for the class. Let's go ahead and make a working copy of working.cpp. We'll paste this into our working project and open it in the editor. I'm going to go ahead and just create a quick and simple little class here. We'll call this class A, and we'll give it one data member. And remember that data member is private because we haven't declared it otherwise. And I'm going to type the word public here. And you'll notice that Eclipse is really nice about flush lefting that for us. And we'll go ahead and declare a couple of public interface methods. And these are what are called accessors, these types of methods, because they're going to be used to access that private data member. First one is setter. So this will set A. So it returns void. And it takes a const int A as its argument. And we'll just say IA equals A, semicolon. And so that's a simple setter. And all that does is it takes its argument and it uses it to set the value of the private data member IA. So we'll go ahead and declare a getter. Now this one will return an int, and it'll be called getA, and it has no argument. And it'll simply return IA like that. And so it's a very simple setter and getter. These are called accessor methods. They're used for accessing private data members, and they're very common. And so that's a very simple little class for our experimenting with here. Now we'll declare an object based on that class. So we do that like that. The capital A is the class type, and the lowercase a is now the object that's an instance of that class. And we'll use our setter to set the value. We'll give it a value of, say, 47. And then we'll use our getter to retrieve the value. And we're going to use cout to display it like that. And we'll just compile and run this, and you'll see that it prints a 47 exactly as we expected. Now we can easily set and get values from our simple class. Now, it's common object-oriented practice, and it's considered best practice actually, to separate the interface from the implementation. This is done by declaring the member functions in the class definition and defining them later. So if I take these member functions and I just copy them and paste them down here, I'm going to go ahead and adjust these first so that they're proper declarations and they're not definitions. So I simply take out the code and the curly braces and put in a semicolon. Now they're definitions instead of declarations. And then I'll take these, and in order to make these actual implementations, I need to declare that they are of this type, that they're part of this class. And I do that by giving them class name with 2 colons like that. Now this is actually proper code, but I'm going to go ahead and format it a little bit so that it's formatted like normal functions. So now what we have is we have our class interface, which is the definition of the class without the definitions of the function members. And we have our implementation, which is the function members by themselves. Normally these would be in separate files. The class definition would be in a file called something like a.hpp. And the class implementation would be in a file called something like a.cpp. And then everything else would be in other files that would be linked to the object file after the compilation process. But for our purposes, for the purposes of teaching, it's really convenient to have all these small little examples in one file. So just know that this is not normally how it's done. There's one other very important detail here that you need to understand at this point, and that's the concept of something called const functions or const safe functions. So we're going to illustrate that by creating another A object, and this one we'll call B, and we'll simply assign the first one to it. So we now have an object B that's of type A, and we have copied object A into B, so it's got exactly the same data members. So we would expect that we would be able to do this and simply say B, and that we would get the same value. I'm going to go ahead and put a string in here so we know which is which. And when I compile and run this, you'll see that we got A is 47 and B is 47. Now, if I take B and I declare it as a const object, like that, with the const keyword, now you notice we immediately get an error. So the error message says, overload of endl, which is just weird, and invalid arguments, candidates are int getA. So the problem here is really with this, invalid arguments. and it's not a very helpful error message. If I save this and compile it, and we'll see what comes out of the compiler, I'm going to go ahead and click the Run in Background button on that. If you get that, you'll do the same thing. Errors exist in project, continue launch, no. Let's take a look at what the errors are here. Here we get a slightly more intelligible error. Passing const A as this argument of int get A discards qualifiers. You'll see that discards qualifiers every time you accidentally do something like this. That's why I wanted to show you that error message. And the problem actually is that this getA function member is not what we call const safe. So in other words, when the object is declared as a const, we cannot use function members that are not const safe. So what does const safe mean? Const safe means that it's been declared as const safe like this with the const keyword. And of course, we need to do it also up here where it's initially declared. So when I do that and I just hit save, that makes this function member const safe. And now I'll be able to compile and run this, and it'll work just fine, exactly as we expect. B is 47. So what exactly does const safe mean? Const safe means I guarantee that I will not do anything in this function that is not safe to do on a const object. And for the most part, that means that I won't change anything. And that if I do change anything, I'm going to do it very explicitly, and I'm going to use special keywords. But for the most part, it really means I'm not going to do anything that's not const safe in this function. I'm not going to actually change anything in this const object. So the rule is a non-const object may use any of the const safe or not const safe methods in the class. But a const object may only use const safe methods in the class. In fact, it's possible to declare two separate versions of this. I'm going to do this right now. One of them const safe and one of them not const safe. And then I can come down here and I can duplicate this and I can make the duplicate not const safe. And just so you can tell which one's being called, I'm just going to put out a little message from each of them, calling this the mutable getA, because mutable is another word that's sometimes used for not const safe, and this one is the const getA. Now, because there are two versions, and one of them's const safe and one of them's not, the mutable version of A, which is this one here, the one that's not declared as a const, that will prefer the mutable version of getA. And the const version of A, the one that's called B, is actually only allowed to use the const version. So we'll go ahead and we'll run this, and you'll see that we get the mutable getA for the first one, and this is the const getA for the second one. So the const function is called for the const object, and the non-const or mutable function is called for non-const objects. So you can remember this simple rule of const functions. Const safe functions may always be called. Non-const safe functions may only be called by non-const objects. So member functions are what make object-oriented programming possible. As we go through the rest of this chapter, you'll see that most of the other features of C++ objects are based on the ability to